The primary focus of this course is to make you think like an attacker attempting to compromise a cloud computing environment so that you can protect cloud computing environments. This is going to be done by us talking about cloud characteristics, models, and threats to cloud services. This is important as a starting point so that we can then apply the hacking process to cloud computing. That feeds into securing cloud identities, so working with cloud-based user accounts and groups, and enabling multi-factor authentication for user accounts. We're then going to be covering how to increase cloud system and data availability through backups and by replicating to alternate regions in case of a regional outage. We're also going to talk about how we can reduce the cloud attack surface. Some of these techniques will be similar to what you might do in an on-premises environment. Think of how often you hear about some kind of digital security breach in the news. Over the years, individual users and enterprises have evolved to using both on-premises and cloud-based services. And so now more than ever, it's crucial that security technicians have a solid understanding of how to secure data and services running in the cloud. And so before we get into how to secure cloud resources, there are some key items that you should already be familiar with. You don't have to be an expert, but you should have a general sense of the concept of virtual machines. If you have experience deploying or managing virtual machines in any environment, that is always helpful. You should have a general sense of how to manage a Windows computer, both at the command line level and the GUI level. You should have a general sense of how to work at the Linux command line. You should be able to use Windows Remote Desktop Protocol, or RDP, to remotely manage a Windows host. You should be able to use Secure Shell or SSH for Linux remote host management. You should also have a general understanding of network concepts such as IP addressing, subnets, and routing. And at the cloud level, you should have some general experience moving around in Amazon Web Services or AWS, as well as Microsoft Azure. The reason is because some of the demos I will be going through will be using both Amazon Web Services and Microsoft Azure. So you do not need to be an expert in these things, but having some experience with them will help you along if you're going through the demos and want to further your knowledge of how to secure cloud services. Cloud computing presents IT services over a network, and those IT services run on somebody else's equipment, specifically the cloud service provider's equipment. This video focuses on identifying the NIST characteristics of cloud computing, where NIST stands for the National Institute of Standards and Technology. We're going to apply a security twist as we talk about these cloud computing characteristics. The first characteristic is measured service, followed by broad network access, resource pooling, rapid elasticity, and finally, on-demand self-service. Let's dive into each of these in detail, beginning with measured service. What we're really talking about here is metered usage of the consumption of cloud services, the same way that you would incur charges at home based on the amount of electricity or water that you use. Charges are based on consumption. Now, this applies to all categories of cloud services, whether you're talking about cloud storage, compute, which would be virtual machines running in the cloud, or network configurations in the cloud, including internet gateways, routing, firewalls, and so on. Now, from a security perspective, we have to think about malicious users that might be able to somehow compromise a cloud admin account and then start deploying services that we are paying for, such as deploying virtual machines in the cloud that might be used for cryptocurrency mining while the organization that is the victim is paying the tab for that. The other characteristic is broad network access. What this means is that cloud services are accessible over a network. Now, the internet would apply when you're talking about a public cloud provider and their services. The intranet, so a local private network to an organization, would apply when you're talking about this in the context of a private cloud. With broad network access, we're also implying that access to cloud services is possible from any type of device, whether it's a desktop, laptop, tablet, smartphone, or even some kind of a specialized device, perhaps medical equipment. Now, from a security perspective, we have to think about the fact that if we've got a public cloud service provider, they are available over the internet. So there is the possibility that more malicious users could attempt to break in since it's directly connected to the internet. That's not to say cloud computing is less secure than doing everything on premises, but it is a consideration. The next cloud computing characteristic is resource pooling. What this really means is that due to the economies of scale, which means because cloud service providers have so many customers, it's very easy for them to provide numerous cloud services at a cheap cost. So it doesn't take much for them to buy the underlying hardware to support cloud services. We have to remember that in the cloud, we have multi-tenancy, which means multiple customers, and they are kept isolated from one another. The other thing we have to think about is resource pooling and what it means for cloud services, whether they are storage-based, compute-based, or network-based. Now, from a security perspective, because all of this hardware, the underlying hardware, resides in a data center owned by a cloud service provider, if we have a data center physical security breach, that could lead to access to the equipment in racks. And, of course, when you have physical access to computing equipment, a lot of security mechanisms will go out the door. And that's one of the reasons why we want to make sure that we encrypt data at rest. So bear in mind that cloud service providers, at least on the internet, public ones, are considered a larger target for attackers. Now, that doesn't mean that it's less secure, because banks could also be considered a larger target than storing the money in your own house. And that's not to say that banks are less secure than storing money in your own house. The next characteristic is rapid elasticity. We're talking here about the quick and easy provisioning and deprovisioning of resources. So adding virtual machines, for example, in the cloud for testing purposes, and then shutting them down and deleting them when they are no longer needed to reduce costs. Horizontal scaling means that we are adding or removing virtual machines to support a busy workload, whereas vertical scaling means modifying an individual virtual machine instance's power, maybe increasing the number of virtual CPUs or the amount of RAM, or maybe even decreasing it. That would be scaling down if you no longer need that horsepower. From a security perspective, because it's so quick and easy to deploy resources in the cloud, we have to think about sprawl. So for example, virtual machine sprawl can occur over time because it's so easy and quick to deploy virtual machines that might be important at one point, but are left running because they're no longer needed. But the more that you have running, the larger the attack surface. Autoscaling is also another part of rapid elasticity. It is related to horizontal scaling. You could configure a threshold, such as if the CPU utilization for a cluster of virtual machines exceeds a given value, because it's too busy, we want to add a certain number of virtual machines to accommodate the increased workload. On-demand self-service is also a cloud computing characteristic. This means that the cloud user or customer can provision resources, like virtual machines and storage and databases and so on. And they can do this using a GUI environment, where they can just make a few clicks, or from a developer's perspective, making API calls to exposed cloud service APIs, or using command line tools, including Microsoft PowerShell. So we're really talking about the cloud user being able to provision or deprovision resources without the assistance of an IT technician. Have you ever wondered how hackers manage to get into cloud computing environments? Well, if you can imagine them breaking into a single organization's network or even into your personal computer or smartphone, then you're on your way to understanding how hackers break into cloud computing. Because cloud computing really just means that we are running IT services on somebody else's equipment somewhere else over the network. So we're going to focus on cloud computing models. That's cloud computing deployment models and individual service models, because having an understanding of this and how it is used can go a long way to help securing IT services in the cloud. So let's take a look at some of these deployment models. We're going to start first with a private cloud. A private cloud means that one organization owns and runs it. All the IT services are managed and used by one organization. And that means then that that organization has full unbridled control and flexibility of configuration of that private cloud environment. In a public cloud, the customer pays to use IT services that are really just hosted on somebody else's equipment in a data center somewhere. However, anybody potentially can subscribe to that public cloud provider to use their services. So examples of public clouds would include Amazon Web Services, Microsoft Azure, Google Cloud Platform, to name just a few. A community cloud is designed to serve organizations that have similar cloud computing needs, perhaps for an industry like the medical industry or at the government department level. An example of which would be the Microsoft Azure for Government Cloud, which meets security standards required by U.S. government agencies. Continuing, there are other cloud deployment models, including a hybrid cloud, which combines various clouds, for example, public and private clouds, together, or a distributed cloud, which presents itself as a single unified cloud, but consists of multiple cloud deployment models, or a polycloud, where a polycloud means that we are actually using multiple cloud providers. Why would we do that? Simply perhaps because we prefer the services of cloud provider A in some cases, but in other cases we use cloud provider B for a different set of services that we like to use. It could also be for compatibility reasons with existing legacy apps that we want to migrate into the cloud. The next thing to think about are cloud service models. Now, generally speaking, under one big umbrella, we have XaaS. This stands for Anything as a Service. And what we're talking about when we discuss this type of thing, service deployment models, we're talking about managed services that run in the cloud on cloud provider hardware. And depending on what exactly you're using will determine how much you have to configure of the underlying servers or underlying software. So a managed service means it's hosted in the cloud, minimal setup by user. And metered usage means that we pay for what we use. For example, you might be charged by the hour or even by the minute for running virtual machines in the cloud. Let's talk about some specific service models, starting with Infrastructure as a Service, or IaaS, IaaS. So what this refers to is the underlying infrastructure that supports IT services, things like storage, networking, and virtual machines. The next thing to consider are other cloud service models like Platform as a Service, or PaaS, P-A-A-S. This would include things like databases and custom functions that software developers can build and host in the cloud. The beauty here is that the setting up of the underlying servers and software is already taken care of for us. Desktop as a Service, or DaaS, D-A-A-S, allows us to have user desktops, whether they're Linux or Windows-based, hosted in the cloud. Users would use a device to make a remote connection as if they were sitting at a desktop computer somewhere. Software as a Service, or SaaS, S-A-A-S, examples of which would include Microsoft 365, Google Docs. Then Mobile Backend as a Service, or MBaaS. This allows us to link mobile device apps to cloud resources like backend databases. So MBaaS would be of primary interest to software developers. Firewalls as a Service, FWaaS, cloud-hosted firewalls. Machines as a Service, or MAAS, MAAS, is used by the manufacturing industry for IT solutions that are hosted or managed by a third party. So in summary, what have we gone through here? We've discussed cloud deployment models like public, private, hybrid, and community. We discussed cloud service models, of which there are many categories, like Platform as a Service, where a lot of the underlying work is taken care of for you. We discussed the security implications of cloud computing in the sense that we've got all of these services running on somebody else's equipment. Now, that by itself inherently doesn't necessarily mean it's unsafe, much like storing cash under a bed mattress versus in a bank. Just because it's in a bank and it's a central target doesn't mean it's less secure. And you can think of it in the same way when it comes to cloud computing. I'll leave you with this. As a security technician, how would you approach securing cloud services that you might be using within an organization? Now, possible approaches would include seeking cloud service deployment documentation. You need to know how things were deployed, how they're configured, in order to properly secure them. You might determine if there are any data privacy laws or regulations that apply to any data and what you should do about it, such as enabling encryption for data at rest. You should also consider that cloud-based data can also reside locally in on-premises devices that might synchronize with the cloud. So all of these types of things are potential cloud computing security implications. Thinking like a malicious user can help IT technicians prevent security breaches against the use of cloud computing. This video focuses on cloud computing and its relationship to the 5 phases of ethical hacking. The 5 phases of ethical hacking begin with reconnaissance, followed by enumeration, followed by gaining access and maintaining access, and the covering of tracks. Let's apply each of these 5 phases to cloud computing, starting with cloud reconnaissance, which is essentially, from the malicious user's perspective, a fact-finding mission. It's about obtaining information. In the end, the more that an attacker knows about a potential target or victim that's using cloud computing, the better off they are to mount and execute an attack that will succeed. Now, that means finding out a lot of things, such as the cloud service provider used by an organization, which cloud services are being used, how they're being used, and also using technical techniques to learn of things like DNS names of hosts and IP addresses, capturing network traffic with packet capturing tools to examine both packet headers and the contents within the payload of a packet. You can learn a lot about a network that way. Conducting port scans to see what services are running, and also vulnerability scans, which, aside from identifying services, can also identify weaknesses in those services, such as missing patches. So all of this is about getting information about a potential victim from the attacker's perspective. Next, we have the cloud enumeration phase. This means enumerating or listing things in the cloud that have been deployed, like virtual networks, virtual machines, databases that have been deployed, and also enumerating lists of users, groups, and security principals in a centralized network directory. Security principal you can think of as kind of a dummy user account. It allows software entities or software components to have access permissions to other resources, such as a web component having access to read from a backend database. The next phase of ethical hacking is gaining access. In the cloud, as is also the case on premises, social engineering can be used to trick people into divulging sensitive information, such as cloud administrative credentials. This could result in compromised cloud accounts, although sometimes good old guessing will work. If you know the name of someone within an organization and they are cloud users, you might be able to guess and even brute force a user account to get in. And of course, there's always tricking people into clicking on or downloading malware, which can then run from inside of the network. Now, pictured on the screen, we have an example of how to mitigate user account brute force attacks in the Microsoft Azure cloud. This is using a feature called Smart Lockout. We can see here it's configured with the lockout threshold of 4. So after 4 incorrect subsequent login attempts, the account is locked for a number of seconds, specifically here 120. This is the same type of option that has been available in on-premises network environments for decades. The difference here is it applies to cloud accounts. We even see in the middle here that we can enforce a custom list of banned passwords that are easily guessed that we don't want our cloud users to use. Next phase is the maintaining of access phase after having compromised a system. Now, often what attackers will do is create a backdoor to evade detection after they initially gain access. Now, that might be done by creating a user account that looks like it should be there, such as a service account or a software entity account. Now, the creation of these new user accounts is often done such that the accounts have raised privileges. And so if you conduct periodic user permission auditing, you can uncover some of these instances if they exist. Depending on the objective of the attacker, this maintaining of access could be short-term or long-term. There have been publicized events in the media about attacks whereby the perpetrators had access to company networks for months, in some cases even years, before they were discovered. The last phase of ethical hacking is covering tracks. Attackers want to make sure they don't get caught and that their activities remain unknown. And so this means removing log entries and audit records from individual apps and hosts and even specific network devices like firewalls, routers, VPN appliances, that type of thing. So from the security analyst perspective, you should always be looking for missing time frames in logs that could indicate that that part of the log was wiped by an attacker to cover their tracks. should also make sure that you have centralized logging and that log alerts are enabled so that if log entries that meet conditions are met and they show up, administrators get notified, and also if logs get modified, that administrators are notified. Some traditional threats that apply to on-premises computing and software development also apply to the cloud. Take a moment to think about past security incidents that might have occurred in your on-premises network environment. How could those incidents be applied to your organization's use of cloud computing? Because usually we have lessons learned from security incidents and how they were handled to either reduce their impact in the future or to ensure they don't happen again. And that's the stance or the perspective we want to approach this discussion from. So let's begin here by talking about potential cloud computing threats. And you might say to yourself, wow, a lot of these are also really threats to an on-premises network environment. You would be correct in thinking that. First of all, internet visibility of cloud services. Let's say you deploy a Linux virtual machine in the cloud. If you give that machine a public IP address and it's listening on port 22 for SSH remote management sessions, that could be a vulnerability because it's exposed to the internet. Attackers could scan the internet looking for any listening services and start to try to attack it. The other thing to think about is not implementing storage encryption. We need to encrypt data at rest where appropriate, such as to be compliant with certain data privacy regulations. A lack of IT personnel cloud training. Just because we might have a lot of experience working with servers, managing users and desktops on premises, that doesn't necessarily mean we automatically know how to deploy, manage, and secure everything in the cloud. So cloud training, absolutely paramount. Social engineering is the deception or the tricking of users into divulging sensitive information. And that can come in many ways, like through an SMS text message or an email message where the user is tricked into clicking a link. So we can have malware infections on premises as well as in the cloud. The next thing to think about is using specific services within a cloud provider, because that's really where it is. As the saying goes, the devil is in the details when it comes to securing these things. Pictured on the screen, we've got a screenshot of a storage bucket in the Amazon Web Services cloud. Notice that there's a note here that says publicly accessible in our screenshot, which means what it says, anybody can access the files in this bucket without authenticating. And that might be legitimate in some cases. Maybe this serves as a back-end storage facility for a public website, and this is simply product documentation. So you have to think about context to determine if something is a potential cloud computing threat or not. But if you've got some files in the bucket that are sensitive, maybe the solution would be to place those in a separate bucket that is not publicly accessible. And there are many tools out there that can be used to enumerate or go through and list any potential security vulnerabilities, such as an Amazon Web Services S3 bucket, as they call it. S3 stands for Simple Storage Service, in case you're wondering. There are two tools that come to mind, one of which is S3 Inspector, the other which is S3 Scanner. So yes, there are tools out there that allow us to scan for vulnerabilities in the cloud, but depending on how they're used and who they're used by, it could also be used as a way to attack a cloud computing environment. So in our screenshot, we see the help screen for S3 Scanner. The S3 Scanner is a tool that lets you find S3 buckets and, if possible, dump the contents of what are stored in them, such as if it's a publicly accessible bucket. Other common cloud attacks would include things like cloud snooper attacks. Often this happens because we have a rootkit infection on something running in the cloud, like a Linux virtual machine, which would allow attackers to get into that environment because they've got an infected host. Well, yeah, okay, but what does that mean exactly? Well, what it means is that the attacker will have somehow tricked a user into installing rootkit malware on a virtual machine in the cloud. And so what happens then is that malware might be programmed to periodically go out to the internet from inside the cloud to retrieve commands on what it should be doing. And that traffic, that command and control, or C2 traffic as it's called, can be disguised as legitimate traffic such as DNS client query traffic. Another type of attack is the Instance Metadata Service, or the IMDS attack. This is specific to AWS virtual machines, which are otherwise called EC2 instances. They run a service that will return details about themselves, such as any roles that are assigned to the VM, so that the VM has access to other things like maybe storage buckets. Also, it'll return any details about access keys configured for that specific VM. Access keys, as the name implies, give access to something specific. You might have different users in the organization with different access keys that allow them to authenticate programmatically to AWS. Another common cloud attack is a Content Delivery Network, or CDN, cache poisoning attack, where a CDN is really a copy of data from origin web servers, for example, and we have a copy of it because it's stored strategically in a region near users that will request it, thereby reducing the amount of time it takes to deliver that content to users. Now, what's the attack here then? Well, malicious content might be injected, or it also could mean that a malicious content request is sent that allows access to back-end origin servers. It could also result in a denial of service or a DOS attack to bring a server down, or could end up being malicious content delivered to users because that malicious content was injected into the CDN cache. We've also got golden security assertion markup language, or SAML, types of attacks. What this does is compromises an identity provider private key that is then used by the attacker to forge authentication tokens. When it comes to security and cryptography, public and private keys can be issued to entities like identity providers. The public key can be shared with anybody, that's why it's called public, but the private key must be kept private. If someone gets a hold of the private key, they can forge requests or transactions as if they were the legitimate key owner. And then we have serverless-based attacks. What does serverless mean? It means that the underlying server, or could be multiple servers, are configured and managed by the cloud service provider, the CSP, automatically. You don't have to manually deploy virtual machines in the cloud and configure software on them. So software developers then can focus on writing code when it comes to this type of environment, a serverless environment, instead of the developers spending their time installing servers. So examples of software developer environments with serverless-based solutions include AWS Lambda, Azure Functions, Google Cloud Functions. So there are plenty of options available out there. Also, the other thing about this that makes it very attractive to software developers is that auto-scaling can be enabled when code requests get busy. So as things get busy, auto-scaling might add additional underlying services to handle the peak workload. So what we've seen here then is that many of the same vulnerabilities that you might already be familiar with on premises can also be present in the cloud. So imagine that you're the team lead for software developers and you're using serverless cloud functions. What security advice would you impart to your team? Well, one of them might be to follow secure coding guidelines, since we're talking about software developers, not hard coding credentials into code like database connection strings, and also using built-in solutions to protect these items. As an example, using the AWS Web Application Firewall to protect Lambda functions. Controlling resource access in the cloud is similar to controlling IT resource access on premises, and that's where cloud identity management comes in. It involves identifying users or software that require specific privileges in order to get things done. Now think about your cloud computing environment. How are users authenticated? Where do the user accounts exist? And what resources do they have access to? Well, we'll be able to determine some of those types of answers by knowing where to look and knowing how these mechanisms work together in the cloud. Let's start with cloud users. Cloud users can be created directly in the cloud account that you happen to be using. What this means is that if you're using AWS, Amazon Web Services, for example, you could go into Identity and Access Management, or IAM, within AWS and create user accounts there. Of course, the process will differ depending on the cloud provider that you're working with. So users then can be created in a cloud-based directory service. Users in an on-premises directory service can be linked to the cloud. Imagine that you have Microsoft Active Directory being used in an on-premises network environment, where you've got an Active Directory domain with a bunch of user accounts. Well, you can link that to the cloud so that users can continue to use their familiar on-premises credentials to access cloud-based applications. You can also work with federated user identities from external identity providers. Think of things like when you sign into a web app online, you might sometimes be prompted, instead of creating a user account, to sign in with your existing Google, Facebook, or Apple account. That's identity federation, where you have a trusted third party that can be used for authenticating to apps. So take a moment and think, where are your cloud user accounts and how are they used to authenticate? The other thing to think about is organizing users into groups. Now, this is an age-old mechanism, of course, when it comes to IT network admin. The idea is that we group user accounts with similar needs into groups, and then permissions get assigned to the groups. It's just much easier to manage, especially at scale, than assigning permissions to every individual user. Group membership can be assigned, and what that means is that you manually add members to the group, or it can be dynamic. Dynamic means that the group is configured with an expression, or multiple expressions, that might look at user accounts and their attributes to determine if they should be a part of a group. As an example, I might have a dynamic group expression that says, if city equals Milan, then I want users to be a member of this group. And also, users might request to be joined to a group so that they can enjoy the privileges that come with being a member of that group. Another aspect of cloud identity management are cloud roles. Now, cloud roles are similar to a user account, but the idea is that we use the role to grant permissions to services or software. For example, in the past, you might have been used to creating a dummy user account and then associating that with a software program, maybe because it needs access to the file system on a server. Well, instead of creating dummy user accounts, you can create roles and assign permissions to the roles, and the software would use that role. In Amazon Web Services or AWS, that's called an IAM role. In the Microsoft Azure cloud environment, similarly, we have what are called managed identities. Again, this might be associated with a virtual machine that needs to have access to read cloud-stored data, as just one of many potential examples. The other thing to think about with identity management is multi-factor authentication. Something you wire is biometric authentication, such as fingerprint scanning or facial recognition. Something you have might require you to have your smartphone with some kind of an app that generates a unique code. Maybe you need that to sign in with multi-factor authentication to connect to the cloud, maybe even to connect into a VPN. Then we have the category of something you know. This is the standard username password type of mechanism. When you combine these different factors, you get multi-factor authentication, and it makes it much more difficult for an attacker to break into an account that uses MFA than it is for breaking into an account that does not use MFA. In Microsoft Azure, role-based access control is called RBAC, and you've got a number of built-in roles, such as virtual machine administrator login. And really, that role just contains the permissions required, in this case, to allow logging into a virtual machine as an admin. So in Azure, these roles are collections of permissions that get assigned to security principals. The security principal might be a user account, it might be a group, it might be a managed identity. And so you could say then that the roles provide access to cloud resources and data. From a security malicious actor perspective, sometimes if a cloud environment is breached, malicious attackers might kind of add a user to a role that otherwise should not be done. And that can be hard to track down if you're not conducting periodic security audits. Another aspect of cloud security and identity management is attackers trying to enumerate cloud accounts and roles to see what's there, because the more that they know, the more that they have when they try to attack a cloud environment. We have a couple of simple examples here of how to enumerate cloud accounts at the command line. You don't have to memorize this, but for example, in PowerShell, in a Microsoft Azure environment, we could create a variable called $role, and we could run the PowerShell command called get-Azure AD directory role, pipe that to where object, which is a filtering mechanism, Well, we want to look for a display name equal to company administrator. So this might be one way that attackers get a list of admin accounts if they can get to the point where they can even read Azure Active Directory. The other thing here that we can do is using the Azure CLI, the command line interface. We would use commands like AZ for Azure, AD for Active Directory, user list. Now, of course, we have to take it for granted that an attacker would have to gain access to the point where they could at least list these things from the cloud account. Now, there are a lot of third-party tools that will do similar types of things, and we need to be aware of these things. We've also got AWS, Amazon Web Services, permissions policies. So a policy is a collection of related resource permissions, such as S3 read-only, which has the permissions to allow read-only access to S3 storage buckets in the AWS cloud, or EC2 full access to allow full access to manage EC2 instances, which are virtual machines. You can always create custom policies if you need to, and policies can be attached to user accounts, so IAM users, groups, or roles. Okay, so with cloud identity security then, we have to think about using MFA and strong passwords to secure accounts. We can even use things like conditional access policies in the Microsoft Azure cloud, where many conditions must be met before a user is authenticated and can access things like cloud-based apps. We should have periodic permissions auditing so that we can identify any anomalies, such as if there was a security breach and a malicious account was created, or perhaps a role was granted to an account that shouldn't have been done. We can also identify things like Cloud Shadow admins. Cloud Shadow admins, again, are just extra accounts that have elevated privileges that might have been created by an attacker that gained access to the system. So by attaching policies or adding group membership where otherwise it should not have been done. So think about your cloud computing environment, where user accounts are, if they're organized into groups, if things like managed identities in Microsoft Azure are being used to assign permissions to software. All of this needs to be documented, and it needs to be reviewed periodically in terms of a security review to make sure that those permissions are still needed and nothing has changed. One important management aspect of cloud security is correctly managing cloud user accounts and cloud groups to ensure, for example, that they only have permissions to the resources that they should have. So in this demo, what we're going to be doing is using the Amazon Web Services or AWS Management Console, the GUI management tool, to work with cloud-based users and groups. To get started here in the console, I'll click in the search field at the top and I will search for IAM, which stands for Identity and Access Management, and I'm going to click on IAM. That puts me in the IAM Management Console, where in the left-hand navigator, I can get a list of user groups that might already exist, users, roles. Now, a role is kind of like a user, except it's assigned to some other entity like a virtual machine, so that the virtual machine would have permissions. And the permissions, of course, come from what are called policies in AWS. A policy is a collection of related permissions. For example, on the right, if I filter the list of policies, let's say for S3. S3 refers to Simple Storage Service. It's a storage bucket or storage location in the AWS cloud. Well, we've got some policies here specific to that, such as allowing full access to S3 buckets or read-only access, whatever the case might be. And you can always, if you need to, create your own custom policy with your own sets of permissions and give it whatever name that you would like. So we're going to start here by going to User Groups over on the left, and I'm going to click Create a Group in the upper right. I'm going to call this HQ_East. HQ for headquarters, let's say. And down below, as I'm creating the group, I can add members or users to the group. However, I'm going to do that later. But what I can do also as I create the group is I can attach permissions policies. I can also do that later as well and change it, but I'm going to do it here. Remember that policies are where permissions come from. So let's say that I want this group to have full access to manage S3 buckets. So if I filter the list of policies here for S3, I can select, let's say, Amazon S3 full access. I could actually select more than one policy here at a time, but I'll just stick with that one. And I'll scroll down to the bottom where in the bottom right, I'll click Create Group. And that's it. The group is now created. It's called HQ_East. And currently, of course, there are no users in it. However, let's go create a user account. I'm going to click Users over on the left, and I'm going to click the Add Users button in the upper right. I'm going to create a user here by the name of JDoe, and I can determine if I want to allow JDoe to access the AWS Management Console itself, the tool that we are using. Now, if JDoe is an assistant cloud technician, maybe that's appropriate. Or if JDoe is a software developer, maybe we don't want them to access the console. Maybe we'll generate some key pairs for them for authenticating at the command line. In this case, I'm going to provide JDoe with access to the AWS Management Console. We can auto-generate a password, which we can view afterwards and communicate to that user, or use a custom password. We can also determine if the user must create a new password at the next sign-in, which always is a good idea. That's checked on automatically. I'm not going to change those items. I'm going to click Next in the bottom right. This is where I can determine if the user should be added to a group. Down below, I can select the group or groups that the user should be a member of. I want JDoe to be a member of HQ East. I simply turn on the check mark. Now, that means that JDoe will also get the benefit of the permissions that come from any attached policies to that group. Now, other than adding a user to the group, for permissions for the new user, I could also opt to copy permissions from an existing entity or attach policies directly to the user account, which is sometimes necessary. But generally speaking, at a management level, it's easier to manage permissions policies at the group level for people with similar needs. Okay, I'm going to go down and click Next in the bottom right, and on the Review and Create page, everything looks good. I'll create the user account. Okay, so now I've got the console sign-in details for the username is here, and the password for the user that was auto-generated is here. I can click Show, I can copy it, I can email the sign-in instructions to the user. But one way or another, make sure you take note of this password and perhaps copy it somewhere else in a safe location. So I'll just go ahead and copy it to my clipboard, and I'm going to choose Return to the Users list, and now I'm back here in the IAM console where I'm in the users view. There's JDoe. Of course, JDoe is a member of that group. Now, if I go into the properties of a user account here and go to security credentials, as a matter of fact, notice up above, it says enabled without MFA. No multi-factor authentication. You really should consider using that. And you can configure that here under security credentials, where I have options down below to assign an MFA device to that user account. So I could give it a name. Let's say we'll just call it Device 1. And down below, we have a number of ways that users could use MFA to sign in with an authenticator app installed on their smartphone, with a security key like a YubiKey device that you physically plug into a USB port on a device like a laptop, or it could be some kind of hardware time-based token. So we have that available as well. So we make the appropriate selection like an authenticator app, and then from there we could choose Next, and then continue through the wizard to enable multi-factor authentication. So that is an important aspect to consider when it comes to the management of IAM user accounts and hardening those accounts. Multi-factor authentication, or MFA, can greatly enhance user sign-in security. This is because instead of an attacker only needing to know a name and a password, an additional factor, such as the possession of a device displaying a PIN, is required to complete authentication. In this video, you'll learn how to enable MFA, multi-factor authentication, for Microsoft Azure user accounts. So here in the Azure portal, I'm going to begin by clicking on the button on the upper left to open the navigator, and going down and clicking on Azure Active Directory, where users exist. I'll click on the users view on the left. Here I've got a user named User1. Now I want to enable MFA for that account. To do that, over on the far upper right, I'll click on More, and I'll choose Multi-Factor Authentication. That opens up a new window, and it's going to show us a list of our Azure AD user accounts and the status for each one for multi-factor authentication. Currently, it's disabled. So I'm going to turn on the check mark to the left of user 1, and over on the far right, I'm going to click Enable, because I want to enable MFA. I'll click the Enable Multi-Factor Auth button. I'll click Close, and we can now see that the multi-factor auth status for user 1 is now showing as enabled. So what we're going to do is sign in as that user account, and we're going to examine the process now that MFA is enabled for that account. To test this, I'm signing into myapps.microsoft.com, and I'm going to connect with our user account. And I will specify the password for the account and click Sign In. Now, after I enter in the correct password, the next thing I will see is it asks for more information. It says your organization needs more information to keep your account secure. Okay, that's because of MFA being enabled. Let's click Next. It's going to want to know some details because we're going to choose that we want to have an authentication phone at our disposal, so a smartphone that we receive a 6-digit code on to complete the authentication process. So I'm going to go ahead and choose the details here related to my phone. So I'll specify Canada, and then I'll specify the number, and I'm going to have it send me a code by text message. Now, I'm then going to have to enter in that code to complete this process. After you enter in the code successfully, you're then ready to proceed. So I'm going to go ahead and click Done. And when it asks me to stay signed in, I'll choose Yes. Now, to truly test this, what we're going to do is log out and log back in once again to see what the entire MFA process feels like now that it's been configured. So as usual, we're going to specify the user account name and also the password for the account. So we still have to know that information. That's something you know. And after we click Sign In, it'll then ask us for the code that was sent to our phone. So I have a text message on my mobile phone. I'm just going to enter in the code within that message. It's a 6-digit code, and I'll click Verify. So this is multi-factor authentication because I have to possess the phone to receive that 6-digit code in the first place. Now back here in the Azure portal, I'm still looking at my list of users in Azure AD. So if I go back into the More button and choose multi-factor authentication, notice that for user 1, it now shows a multi-factor authentication status not of enabled, which it did previously, but instead enforced, because it's now actually in use. It's being enforced. Policies and role-based access control can be used to limit cloud resource management for cloud technicians. In this video, you'll see how to do just that in a Microsoft Azure environment. Here in the Azure portal in the top center bar, I'm going to search for the word sub and I'm going to choose subscriptions. What I'm going to do is assign a role for a group at the subscription level. So I'm going to click on my pay-as-you-go subscription, and in the navigation bar that opens up as a result of that, I can click on Access Control IAM, where IAM stands for Identity and Access Management. When I click that, over on the right, I can click Role Assignments to see any roles that might already have been assigned. But I can also click the Add button up at the top and add a role assignment from here, which I will do. What I'm presented with is an alphabetical list of both built-in and custom roles if custom roles have been created. So let's say I'm interested in allowing other technicians virtual machine management capabilities. So I'm going to type in VIR, and I'm going to choose the virtual machine contributor built-in role. Now, a role is a collection of related permissions that, in this case, will allow the management of virtual machines in the Microsoft Azure cloud. Now, down below, I'm going to select an existing Azure Active Directory group named East_admins. So members of this group will have the permissions for the virtual machine contributor role. I'll click Save, and then we'll be able to see this role assignment listed, because we're still looking at role assignments at the top, over on the right. There it is, virtual machine contributor for the East Admins group for this resource being our pay-as-you-go subscription. Now, interestingly, you can get a little bit more granular when you assign roles. You don't have to assign it at the subscription scope. So for example, let's open up our navigator on the left, and what I want to do, scroll up a little bit and click Resource Groups. In Microsoft Azure, a resource group allows you to group related cloud resources so they can be managed as one unit. For instance, if I were to go into the East RG1 resource group and then click on Access Control IAM for it and look at the role assignments, we're going to see what we just did. It's going to look a little bit different because it's going to say it was inherited from the subscription level. But there it is, virtual machine contributor for the East_admins group. So it's flowing down to all of the cloud resources, such as virtual machines that we might have deployed within this resource group. Now, you can even get more granular than that if you really want to. You can select a specific Azure resource. So for example, let's open up our navigator. Let's click All Resources. But you can choose a specific resource like an individual virtual machine. And in its navigation bar, you do the same thing. You can click on Access Control IAM, and you can view the role assignments, and you'll see that it will have dribbled down or been inherited down to this level as well. Now, of course, you can also click the Add button to add a role assignment at these subordinate levels if you want it to be a little more controlled. Now, that's an RBAC role. But what I can't do with roles, for instance, is check whether encryption is enabled for virtual machine disks, that type of thing. That's where policies come in. So here in the portal in the top center, I'm going to search for POL, and I'm going to choose policy. Now, there are a number of built-in policies that you can use to check for security compliance for your resources in the cloud. So I'm going to click Assignments over in the left-hand navigation bar, and I'm going to choose Assign Policy up at the top. Now, I have to determine the scope, which is automatically set to my pay-as-you-go subscription, but I could click on the Scope Selector button on the right, and I could choose a resource group instead of having my entire subscription checked. Now, when I say checked, what we're going to do is check that virtual machines have their disks encrypted. So I want to check the entire subscription, all virtual machines, so I don't want to specify a resource group. So I'm going to cancel out of that. I don't have any exclusions, but I have to select the policy definition. So I'll click the button to the right of that field, and I can filter it by name. So maybe I'll choose or type encrypt. Here we go. Disk encryption should be applied on virtual machines. It's a built-in policy. Okay, I'm going to select that. Click select, and it's now done. And there's really nothing else I have to do here. Of course, the policy enforcement is enabled here. Okay, so all it's going to do for existing virtual machines that do not have encryption for disks, it'll simply flag them as non-compliant. Let's choose Review and Create to create the assignment, and then Create. Now, depending on the size of your Azure subscription, how many objects you've created in the cloud will determine really how long this takes. It might take just a few minutes, or it might take an hour. So all I would do here is click on Compliance, and again, I'll see if anything has been done. So we can see here, disk encryption should be applied. It says the compliance state not even started. So I can keep coming back here periodically every few minutes and clicking refresh until I see the compliance report that states whether virtual machine disks are encrypted or not. So after a few minutes, we can see the compliance state is now listed as non-compliant. So I'm going to click to open that up so we can see details such as which virtual machines are non-compliant, which ones do not have disk encryption enabled. So we've got one non-compliant resource, and if I scroll all the way down, I can see it's actually my Windows Server 2016 virtual machine. In this demonstration, we're going to take a look at how to configure AWS resource permissions. So if you're using a cloud computing solution, think about the resources that might need protection. Do you have any databases deployed in the cloud? Are you running any web applications or virtual machines in the cloud? These are important things to know in order to properly secure a cloud computing environment. You need documentation or at least access to sign in to take a look at what's been done previously. So here in the AWS Management Console, I'm going to begin by going into the search bar and searching for IAM, Identity and Access Management, where we have a list of our users in the AWS cloud. We also have a list of groups. We also have a list of roles which we can assign to various services like virtual machines if perhaps code in a virtual machine needs access to something. And the permissions all stem from what are called policies here. Policies are collections of related permissions, whether it comes in the form of managing VPNs or accessing Glacier storage archives and having read-only access to that. There are a lot of these built-in policies, or you can create your own. So what I want to do here in this particular case is point out that when we go into an individual user account, let's say JDoe, one of the things that we can view about permissions is what permissions the user currently has. So for example, under the Permissions tab, user JDoe has the Amazon S3 full access permissions policy to give full access to S3 buckets. And notice that comes from a group that the user is in called HQ East. But then the user has a second permissions policy called IAMUserChangePassword, which was assigned directly to the individual user. And that's fine. You can have a hybrid of these policy assignments where it makes the most sense. Now, at the same time, it's also important to understand that we can assign roles permissions for resources. So we've got all of these role names here. Well, what we can do is use it in the following manner. So if I were to search for EC2, that's the Elastic Compute Cloud. That stands for virtual machines, basically running in the AWS cloud. If I go into the EC2 console and go to the instances view, I've got an instance running here. It's a virtual machine. It's called App1 Windows Server. If I select that virtual machine, and if I go to Actions, I can go all the way down to Security, where I can modify the IAM role. We were just looking at that view. What I can do here is I can choose an IAM role here from the list, or I can create a new one. So for example, create new IAM role. That opens a new browser window, and I can create a role here by clicking Create Role. It's going to be for an AWS service, in this case EC2, so it's a virtual machine. I could choose other items from the list as appropriate, but this is what I want it for. I would click Next, and let's say I need whatever code is running in the virtual machine to have full access to S3 buckets. So I could filter for S3, choose Amazon S3 full access. It could be any other set of permissions that are needed. This is simply an example. Then I could go down and click Next, give this a name, let's say App1 Bucket Role 1. And the actual JSON representation of those permissions are shown below, which is fine. I'm okay with that. I'm just going to go in the bottom right and click Create Role. Okay, so it's creating the role. The role was created. So if we go back to our original screen where we were in the properties of the virtual machine modifying its IAM role, I can click the refresh button, and from the list, I can now choose App1, Bucket Role 1, and update the IAM role for that virtual machine. So now any scripts or code running in that virtual machine would have that permission based on the role we just created to access S3 buckets. Now, this is very important for a number of reasons. One of which, this is a way that an attacker can essentially create elevated privileges and hide it and make it hard to find by admins, because it's not even its own separate user account, it's a role, and that role was attached to a virtual machine. So if they can somehow put code or a malicious script in the virtual machine, it might have more access than it really should to something. Of course, the attacker would have to have the ability to do this in the first place, but these things do happen. And so it's very important then to think about AWS resource permissions and how it can be exploited by malicious actors. So think about your environment. I'll leave you with this. Where are your user accounts? Are you using roles to assign permissions to services like virtual machines? And if so, what are the permissions? And the last thing I'll leave with you is think about how would you detect in your environments if this were being exploited? Generally, the answer would be by conducting periodic security reviews. Making sure that IT systems and data are available in the cloud enables business continuity. And so this video focuses on strategies that will keep things running in the cloud, even in the event of a network attack or a security breach. The first thing about high availability is looking at risk management. These are risks that could potentially jeopardize business processes. The first thing to do is to identify assets. For example, it could be an e-commerce website that generates hundreds of thousands of dollars per day in revenue for the organization. So the asset would be the functioning of that system and the database that stores customer information and transaction information. The next thing to do is to identify potential threats against those assets, such as a data breach that would reveal sensitive customer information. Then we look at the threat likelihood. What are the chances, or what is the likelihood that this could occur? You could even do a historical analysis of past incidents to determine the current likelihood of that threat being realized. And then identifying threat mitigations. These are security controls. So in this particular case, the mitigating control might be to use AES 256-bit encryption to protect the customer database. Finally, always remember that you need to conduct periodic assessments of security controls to ensure that they remain effective. The other thing to consider for availability is at the network level, having redundant network connections. Now, this is especially true if you are linking to the cloud from your on-premises network and you depend on services running in the cloud. You might want to make sure that over the internet or through a dedicated circuit, does not traverse the internet, you have multiple connections, such as through multiple internet service providers, so that if one connection becomes unavailable, the other one ideally will still be available, thus allowing the access of cloud resources. The next thing to consider for availability is data itself and where it resides. So data replication. So we can replicate files that are stored in the cloud to alternate regions. You can also replicate databases. You can create database replicas. You can also replicate virtual machines and the app workloads that they are running. Now, the idea is that we can have this replicated to alternate regions geographically so that in the event of a regional outage, we still have the data elsewhere. But the thing to keep in mind is regulatory compliance. Think about the legal jurisdiction as well based on the location of data that has been replicated. The next consideration for availability is backups, such as backing up on-premises sources like file servers into the cloud, and also backing up cloud workloads into the cloud as well. We have to consider the recovery time objective, or the RTO. This is part of a disaster recovery plan. The recovery time objective is all about the maximum amount of tolerable downtime for a given process, such as our fabled e-commerce website. The next consideration, also a part of a disaster recovery plan, for backups for sure, is the recovery point objective, or the RPO. This one really stipulates the maximum amount of tolerable data loss. And for example, if that's 4 hours, then we need to make sure that we are taking backups at least once every 4 hours. We also have to consider the frequency of backups. That's part of the RPO, and how long backups are retained. We might be bound by contracts or laws or regulations that stipulate how long backed up data needs to be kept available. Finally, we have to consider application resiliency to make sure that an important application remains available. And we could do this through load balancing. You could load balance internal line of business applications used only by employees, or you could load balance a public-facing web app. The idea is that you've got a front-end IP address, and DNS needs to resolve the name of the app to that IP, so client requests are directed to the load balancer front-end IP address, which then determines where the request will be sent to in the backend. You have a backend pool of application VMs serving up the app. Now, this increases availability because let's say you've got 3 virtual machines serving up an app behind a load balancer. If one of those VMs is unavailable, you still have 2 that can service client requests. Not only does it increase availability, but it can also help improve performance for a busy app workload. Having a trusted advisor helps with informed decision-making. In this video, you'll learn about cloud services that can be used to analyze cloud deployments looking for security deficiencies. Here in Microsoft Azure, we can do that in the portal by opening up the navigator in the upper left and then scrolling down and clicking on Security Center. The Azure Security Center is an automatic tool, meaning that you don't have to populate it with data. So based on the cloud resources you deploy and how they're configured, will determine what shows up here in the Security Center by default. So the first thing I see is policy and compliance. It's even broken down by some common regulations and industry security standards like ISO 27001, also PCI DSS. And we can see for each of these how many past controls we have. So 35 out of 37 is good for PCI DSS. But then as we go further down, we see under resource security hygiene that we've got some problems. We see a lot of red here, high severity issues. And on the right, I can see it's broken down. So in the compute and apps resources category, we have 1 severe issue. And in the networking section, we have 3. Let's start by clicking on compute and apps resources to see what's up. we can see it tells us monitoring agent health issues should be resolved on your machines. This is within virtual machines. We see we've got one virtual machine that doesn't have health monitoring installed within it. So we can click on that item to get more details. So at the top, we have a description about the issue at hand. But as we go further down, we'll see the machines that are not compliant. In this case, it's one virtual machine, and we have a link to it if we want to manage it. I'm going to close out of this by clicking the X in the upper right. The next issue we have is that disk encryption needs to be applied on the virtual machines that don't have it enabled. Again, if I click on it, I can read about exactly how that could be done. And as we scroll down, I can also see the affected resources. Here, it's the same virtual machine. Close out of that by clicking the X, and I'll click the X on the next screen. Now, the next thing we're going to take a look at are the networking resource security issues that really need our attention. So I'm going to click on that as well. So we can see if we scroll down a little bit here, we've got an issue with one subnet. The subnet needs to be associated with the network security group. Once again, I can click on that item to read detail about what they're referring to. Sometimes you might get a security recommendation in the cloud that is related to something you don't have experience with configuring. And so sometimes it can be helpful to read a bit on it here and then click the Learn links over on the right to get more documentation about the issue at hand. And again, I can see in this case, the unhealthy affected resource is a subnet called Subnet 1. The next thing that we see listed here is that Distributed Denial of Service, or DDoS protection standard, should be enabled. And again, this would apply to networks and or subnets. So if we scroll down, we can see it's referring to a virtual network called VNet1. And of course, subnets are contained within that VNet. So the great thing about working with a tool like the Azure Security Center is that it's automated in that it's populated automatically, and all of these items are populated automatically as well and categorized for you. So it's a centralized one-stop shopping way of addressing security concerns in your Azure cloud environment. Firewalls control inbound and outbound network traffic flow. In this demonstration, we're going to take that to a cloud context. Think about your network environments. What kinds of firewalls do you have in place? Whether it's for an on-premises business network or even a home network, let alone a cloud environment. Well, let's start by exploring cloud virtual networking, and then we will evolve the discussion to get into firewalling. So let's start here in Amazon Web Services. I've already signed into my account, and so I'm in the AWS Management Console. I'm going to search for VPC, and I'll click that in the list. VPC stands for Virtual Private Cloud. All it really is a network definition in the cloud. So it's a virtual network. If I click Your VPCs on the left, VPC1, as it's called, is now shown over here on the right with its IPv4 address range and optionally IPv6 if I had configured it. If I click Subnets on the left, within VPC1, I have a subnet called Subnet 1. Okay, so we've got a network here. Now imagine that you're doing this on premises. What do you do to control traffic to things like virtual machines deployed to Subnet 1? Well, one thing you would think about is firewall, software firewall, for example. So the way that that works is through what's called a network ACL, a NACL, N-A-C-L. At the top, if I were to search for network ACL, it just shows VPC. Well, that's because in the left-hand navigator here, if I go further down under security, we've got network ACLs. If I click here, I can get a list of existing ones I can manage, or I could create a new network ACL. I'm going to call this Windows Standard. I'm going to tie this to VPC1, my virtual network, and then I'm going to choose Create Network ACL. Now you might wonder, what did that do? Nothing so far, because what we need to do is we need to click to open up that network ACL in which we can then manage inbound and outbound rules to control traffic flow into and out of VPC1. So currently, notice that for inbound rules, all traffic, all protocols, all port ranges from everywhere is denied. So if I click Edit Inbound Rules, let's say I want to allow network management for remote desktop protocol for Windows. I could click Add New Rule. I'll call it RDP, let's say. I'm going to give this a rule number of 100. The rule numbers are relative to one another. What this means is that rule 100 would get checked before rule 101. So instead of custom TCP, I'm going to open up that list of protocols, and I'm going to go all the way down the list to the point where I can select RDP, which uses TCP port 3389. I can allow that from any source location, and in IPv4, of course, that's 0.0.0.0/0. Really, at this level, this is no different than configuring any type of firewall rule anywhere. However, if I know that I've got a specific network range on premises that I want to allow this type of connection from, I can specify that IP address range here in CIDR format with a slash and the number of bits in the network mask. And I can determine if I want to allow or deny that traffic. I want to allow it. So I'm going to click Save. And now we've allowed RDP traffic into that subnet. Any other traffic is going to flow down to the last rule here, which will simply be denied. So that's one way that you can work with security in the cloud. There are many other ways, but just to point something out here, we've also got something called a security group in Amazon Web Services. I'll just open up an existing security group and we'll take a look at it. It looks similar in that we've got inbound and outbound rules, but you know what's interesting is that if we take a look at the details of one of these rules, there's no allow or deny. So with security groups, you have a list of what should be allowed. Not only that, when you're looking at a security group, understand that it gets associated with specific virtual machines, not entire subnets. So the last thing I'll leave you with is how you might leverage some of these solutions to protect resources in the cloud at the network level. It's not the only security defense you should have, but it is part of the layered approach. Laws and regulations can influence how cloud services are used by an organization. After watching this video, you'll be able to recognize how compliance can have a direct impact on cloud service configurations. The first thing to keep in mind is what type of data the organization is storing in the cloud, whether it's individual files or databases, virtual machine disks, or backups stored in the cloud. Now, after we've identified that, we then have to think about where that data resides. Are we replicating any of that data to different geographical regions supported by the cloud service provider? Now, you would do that to increase availability in case of a regional outage of some kind. But you also have to think about how your data is stored and whether or not you are being compliant with the appropriate regulations, such as perhaps requiring encryption for data at rest, even in the cloud. Then you have to think about the potential legal implications based on where data is stored. If you are replicating data to servers that exist in data centers in different countries around the world, there could be different laws that apply, such as for how law enforcement can subpoena that physical equipment in that data center in that country. The General Data Protection Regulation, or GDPR, is a European Union act of legislation. It's all about protecting EU citizen private data. And it applies to any organization anywhere in the world that is gathering, processing, storing, or sharing European Union citizen data. The idea is that EU citizens have control of their private data and how it's used, and that includes its accuracy. So when you're looking at cloud service providers, one thing to do is to take a look at compliance reports to see if they're compliant with any regulations that might apply to your organization's needs, such as whether or not the cloud service provider is GDPR compliant. The Payment Card Industry Data Security Standard, otherwise called PCI DSS, is not an act of legislation. Instead, it's an industry security standard. And it really is all about the safekeeping of credit card holder data, whether it's Visa, MasterCard, or American Express, for example. And there are slight variations in the security requirements between each of those three credit card vendors. But when you look at PCI DSS documentation, what you'll notice is that there are very general statements regarding how to secure something. In other words, there are no specific implementation details provided. That's left to the security professional or the cloud security analyst to determine. Pictured on the screen, we see a PCI DSS certification message on the Amazon Web Services, or AWS, website that states that Amazon Web Services is PCI DSS certified. Now, you can actually read the compliance reports and determine which third party, ideally independent, auditing team conducted this assessment. And you should always take a look at other types of regulations or laws that you need compliance with for your provider, such as GDPR. Now, the thing to watch out for, though, is just because the cloud service provider is compliant with the standard like PCI DSS, it doesn't automatically mean anything you do in that cloud provider environment is also PCI DSS compliant. Replicating cloud-stored data provides a backup as well as an alternate copy of data in case disaster strikes. After watching this video, you will have acquired the skills necessary to configure cloud storage replication. Here in the Azure portal, I'm going to start by opening up the navigator in the upper left. Then I'm going to go down and click on Storage Accounts. In the Azure cloud, a storage account is a storage location for cloud files. So I've got an existing storage account listed here. I'm going to click on it to open it up. Now, I'm looking at the properties here in the left-hand navigator, and if I go all the way down, I can see under Settings an option called Georeplication. However, when I go to georeplication, I have a map of the world, and I've got a blue indicator for where the data currently resides with this storage account down below. The legend says that's the primary location, and it's Canada East. Okay, but where's the option to replicate elsewhere to an alternate region? Well, it's not here yet because of the way this account is configured. If we look at the configuration on the left, we can see that replication for this storage account has been set to locally redundant storage. That means across equipment racks, but within a data center, so it's not replicating across regions. So I'm going to open up that drop-down list and choose Geo-Redundant Storage, and I'm going to click Save. So it says it successfully updated our storage account with the new config change. Let's go back to Geo-Replication. This time, we see two indicators of different colors on the world map. Well, let's see what the legend says. The primary location blue is Canada East. Well, that's where the data resides now. It suggests replicating to Canada Central as a secondary location. That sounds perfect. So now that we've got that option made available, we can rest assured that we have a secondary copy of the data for files stored in this Azure storage account. Replicating cloud virtual machines provides a backup as well as an alternate copy of the virtual machine in case disaster strikes. After watching this video, you will have acquired the skills necessary to configure cloud virtual machine replication. Here in the Microsoft Azure portal, I'm going to start by opening up the navigator on the left and clicking on the Virtual Machines view. I've got a single virtual machine named WinServe 2016. Click to open up its properties. In the navigation bar that follows, I'm going to scroll all the way down under the Operations section, and then I'm going to click Disaster Recovery. Now, what we're going to see is a map with indications of where the current copy of that virtual machine exists. So if we scroll down here, the source region, which is blue here, is Canada East, and we've got a number of available target regions here listed in green, and the selected target region that was automatically selected by Azure and suggested is Canada Central, because it's reasonably close, yet it still provides high availability because it's a different region. So I can change my selection from the drop-down list at the top, but I'm good with what it suggested. It makes sense. So I'm going to go ahead and click Review and Start Replication at the bottom. Now on the summary screen here, before we actually do this, we can see both the source and destination or replica managed disk name. It's going to make a new one. So that's fine. I'm going to go ahead and click Start Replication and let it take care of it. You can monitor the progress by clicking the bell notification icon in the upper right, and we can see that it's currently in the midst of enabling replication for one virtual machine. So after a few minutes, if I click on something else in the properties of this virtual machine and then go all the way back down under Operations and choose Disaster Recovery, we'll see that the availability of this virtual machine has been increased because we now have it replicated. So we can see that the replication health is healthy. The status of this virtual machine, listed up here in the upper left, is now stated as being protected. We also have the option of testing failover. This way we can ensure that in the event that there is a regional outage, we do have the ability to make a connection to the secondary replicated copy of the virtual machine. Load balancing for applications can not only ensure optimal performance and availability for the app, but it can also provide a security service. So for example, a load balancer can serve as a mitigation technique for network flood attacks because you've got multiple back-end servers handling the load. It's not the only thing you should do to mitigate those types of attacks like DDoS attacks, but it's something to consider. And so in this example, let's go ahead and let's configure a load balancer. From a security perspective, high availability is important, making sure that IT services that are critical can be reached even if we have a failure of one or more back-end servers for whatever reason. So let's get started with this. Here in Amazon Web Services, I'm going to begin in the console by searching for EC2, and I'll click on EC2. That will give me the ability to view my virtual machines, my instances. If I go to the instances view, I've got 2 app servers here, and they're both in a running state. Now, realistically, you would install perhaps a web server stack in each of those servers, and the same application files would be configured on those hosts. That's a separate topic. Let's assume that's been done. I want to load balance between those 2 servers. To do that, I'm going to scroll down in the left-hand navigator, and way down under load balancing, I'll click Load Balancers. And then I'll click Create Load Balancer. I want to create a network load balancer, which simply looks at things like an IP address and a port number, and then forwards it to back-end servers to host client sessions. An application load balancer is a little bit different because it can look at the incoming URL string and make a decision as to which back-end server or servers should handle that request. Maybe there's a back-end server optimized for video file uploads or something along those lines. So we're going to go with a network load balancer. I'll click Create under that heading. I'm going to call it App1 LB1 for Load Balancer 1. Down below, it will be an internet-facing load balancer because I want to service client requests over the internet for the app. It could very well be an internal line of business app. You make the appropriate choice here. I'm going to scroll down further because I have to map this to a VPC, to a network in the cloud, and I've already got one called VPC1. And I've got some subnets, and I've also got virtual machines or instances deployed into the US East 1C availability zone. An availability zone is contained within a geographical region. So I'm going to select that, and subnet 1 pops up. That's all fine. Then I have to configure listeners and routing. So basically, I'm going to allow a listener to be created on TCP port 80. Now, I could also have selected that I want to use port 443 for HTTPS, where I would have a PKI certificate to secure the network connection. But for simplicity in this demo, I'll leave it on TCP port 80. However, what will it forward requests to? This is what the load balancer over the internet will be listening on. Well, when it gets a client request on that port number, where should it send it? And that's where the target group comes in. Now, we don't have an existing target group, so I'm going to go ahead and click the link for Create Target Group. That opens a new browser window where we have to determine how we're going to make a connection to the back-end servers hosting our app. Is it going to be by selecting instances, which we're going to use? These are virtual machines. Or do we want to reference them by IP addresses? We can also load balance a function in the cloud, a Lambda function. Or we could select Application Load Balancer, which we discussed previously. I'm going to leave it on instances. I'm going to give this a name. I'm going to call it App1 Target Group 1. And on the backend servers, they're going to be making their web app available on TCP port 80. So it's in VPC1. That's my network. The health check here allows me to specify how the load balancer will determine that the backend servers are healthy and responsive. So I'm going to leave the default values for that, and it can be a connection check over TCP, it could be over HTTP, connecting to the root of each web server, whatever makes the most sense. Okay, so having done that, I'm going to click Next in the bottom right, where I then have to select the appropriate virtual machine instances based on my network selection. So I'm going to put a check mark by these 2 servers, and then down below, I will choose Include as Pending. Pending means it hasn't had a chance yet to determine if they are healthy based on our health check settings. I don't have a web server running in those hosts in this example, so they're never going to be healthy in this demo, but that's okay. So here I'm going to click Create Target Group in the bottom right. All right, now we've got our target group, so let's go back to the first browser window and click the refresh button so that we can choose our target group, which will be used as a target for forwarding traffic that the load balancer receives. Okay, and there we go. We are good to go. So therefore, in the bottom right, I will choose Create Load Balancer. And at this point, I can click View Load Balancer to go into my view where I've got my load balancers shown, and the load balancer is showing now a state of provisioning. When I go into my load balancer, the DNS name is very important. There is a DNS-A record shown here, so you would have to make sure that you modify your company's DNS zone. Let's say it's mycompany.com, and maybe create a CNAME or an alias record that would point to this, so that client requests to your website, for example, would be forwarded to the load balancer. So think about your network environment. Do you currently have load balancing in place? And if you do, is it for public-facing apps? Is it for internal apps? Do we realize the benefits of using this? Of course, it's going to be primarily high availability. We want to make sure that even if we've got some back-end servers that fail, maybe they're flooded by an attack or they're brought down, or whatever the case might be, that the app can still remain running. Modern-day software developers will often use application containers and even clusters to support busy applications when it comes to software development. Imagine that your organization has a custom web app and that some security changes are needed. Well, instead of bringing the entire app offline, if the app was built using multiple application containers that work together, you would only need to bring down those components, those containers that need changes, while leaving the other ones up and running. So this is one of the many benefits of using application containers. Let's go into some detail about containers and their relationship to security. The first thing we have to do is discuss what an application container is relative to the underlying operating system, because it is not its entire own operating system. It's also not a virtual machine. Let's explain this. So in our diagram at the bottom, we've got the host operating system. That could be Windows-based, it could be a Linux or a Unix variant, but on top of the host OS, you would need to have a container engine running. Software, the most common example of which would be Docker. So let's say we've got Docker installed on our host. That would allow us to run one or more containerized applications, which are shown here labeled as Application Container A, Application Container B, and Application Container C. You can think of an application container as being a logical isolation or a boundary that contains all of the stuff required to make that app work, like binaries, like config files, or even its own little tools that might be specific to that application. All that stuff can be contained within the application container. But the application container does not contain an operating system. It just uses the host OS. So app containers start up very quickly and they're very lightweight as a result of this. Let's go over some other fine details about application containers. So each container would show up in the operating system as a running process. So you could say then that a container is a running instance of a container image. A container image is your starting point that has the definition for whether there's a file system in the container and the files that make up the app and so on. So you start a container from a container image. And each container can even have its own network listening port or ports. For example, it might have an HTTP web server stack listening on port 80 or port 443. And a container can also have its own file system that you could even have mounted into the host operating system for ease of management. But as you might expect, you want to make sure that the underlying host is secured properly, because a compromised host can mean compromised containers for those applications that are running on that machine. Now, ask yourself this: what would you do to harden or secure application containers? Now, if you're thinking, well, I would probably take the same steps I would to harden any application. Make sure software developers adhere to secure coding guidelines, apply the latest updates, make sure only the required network ports are open, have a firewall controlling traffic. All of that normal stuff also applies to containerized applications. Now, Docker, as we've said, is probably the most common example of a container engine for Windows and Linux, on-premises, in the cloud, it doesn't matter. Physical server, virtual machine, it's all the same when it comes to running Docker and containerized apps. You would want to make sure the Docker engine software is also kept up to date. So let's talk security. Here we've got a list we're going to go through of potential vulnerabilities or tools related to containers and what we can do to mitigate that security issue. The first one is the Docker Engine Remote API, which allows remote management over a network to a Docker host. What can we do to harden or secure that? Well, one thing to do is to use only TLS connections. Configure it so it only allows encrypted connections over the network for remote management. The next example of a potential issue is the Cloud Container Attack Tool, otherwise called CCAT. Now, what can we do about this? Because the problem with CCAT is it is designed to enumerate or go through and list Docker references to repositories where images are stored. And even at the network perimeter level, one of the things that you should always be doing is limiting who can be on the network in the first place. That's always one of the first lines of defense, and that would also apply here. The next potential vulnerability or tool is a container volume compromise. Remember how we said an app container might contain its own file system and that file system could be made available in the underlying host for management purposes? Well, you can limit that from happening, and you should really do that only when absolutely necessary. The reason is because if the host is compromised, it's even easier for attackers then to get into the file system of the container without them having to get into the container itself. The next thing to think about with container security is Docker Scan. This is a tool that scans a network for container registries, and it can be used to further escalate attacks by enumerating which container images are in there and trying to break in. What can you do to mitigate it? As always, restrict network access. A lot of these tools are legitimate tools used by security specialists, but if they're used in the wrong hands and the wrong ways, they can be used to start attacks. The enumeration of Kubernetes etcd. Kubernetes is a container cluster environment. It allows you to manage multiple nodes, each handling different application components normally done in the form of an individual container. So you could have multiple containers spread out across the cluster. You'll find that happens quite a lot if you're doing big data analysis and that type of thing. Now, the etcd is a daemon, a running service that contains cluster state data. To protect it from attackers, we could require the use of a PKI certificate when communicating with the cluster nodes. Sysdig, Kubernetes vulnerability scanning. Well, the Sysdig tool allows security specialists to check cluster configurations to make sure they're performing well and that there are no known vulnerabilities. So it's a security monitoring tool. Same with Trivy. The Trivy container vulnerability scanning tool is designed to identify security weaknesses within Kubernetes clusters, even container repositories, and even specific container images. Kubernetes is a clustering solution that can run on-premises or in the cloud. So what can we put in place to secure our containerized environment? We've covered some of this already. If you're thinking restricted network access, host hardening, requiring user login, PKI certificates for encrypting network connections, these are all important. Now, if you want to learn more about containers, look for other titles in the LinkedIn library, such as Learning Docker. Auditing can provide a means of determining if suspicious activity exists in a cloud computing environment. After watching this video, you will have experience viewing cloud-based logs and audit trails. To get started here in the Microsoft Azure portal, I'm going to click in the upper left to open up the navigation bar, then I'll click on All Resources. In the Azure cloud, you can create a log analytics workspace, which I've already done. Let's click to open it up. Now, you can think of this as a centralized log collection type of service, but you have to configure it. If I scroll down under Workspace Data Sources, I can click on Virtual Machines, and I'll have a list of virtual machines that I can click on to either connect or disconnect to or from this workspace. Now, you want to connect virtual machines to the workspace if you want their logged information centrally available here. You can also do the same types of things with other cloud resources like storage accounts. Now, I'm going to open up a demo provided by Microsoft where there's plenty of sample data already made available in a log analytics workspace. I've opened up another web browser window where I'm looking at the page where I can get started with log queries in Azure Monitor. The reason this is important is because this is where you'll have a link to the demo environment. So I'm going to go ahead and click to launch that. This is a log analytics workspace that's populated with a bunch of sample data. Now, this can be important when you're working with real data from your own environment. So let's see how it works. The first thing that we might want to do here is go over to the Query Explorer in the upper right, where there will be all kinds of queries that you can run. Now, we're interested primarily in security and audit, so I'm going to expand that particular section. Now, even though there's not enough space on the screen, you can kind of hover over these to get a sense of what the names of the queries are. For example, here's one, computers whose security log was cleared. That's definitely not a good thing normally. Periodically, administrators might legitimately clear logs, but nonetheless, let's take a look at this activity. So when I click once, it puts the query statement here in the query builder, which you could build yourself manually. Now, right now, the default time range is for the last 24 hours. Let's see what we get when we run the query. Well, we get one computer, and we've got a log cleared count of 1, so we can see the actual computer name. Now, that may or may not be legitimate, but let's see what we get if we go back further in time. So the first thing I'll do is close the Query Explorer, click Time Range. I'll choose Custom. Maybe we'll just go back a few years to see what else we get. I'll click Apply, and I'll click Run to run the query again, this time with the custom time range. And again, it looks like we have the same returned result. So what we're getting here is a list of the host and the number of times the log was cleared. Now, because the query really is built the way it is, we're not seeing all of the information that's available. And you can tweak and customize this. However, let's go and run a different query. So I'm going to click Query Explorer on the far right. Again, I'm going to go, let's see, down under Solution Queries and down under Security and Audit. Now, if we take a look, we've got another query here, computers missing security updates. That is a problem because it means our environment potentially is not as hardened as it should be. Well, let's see what the results are from the query. So I'm going to click once to put that into the query builder, and I'll click Run. Once again, we have a number of computers that are listed here. Let's just kind of expand this. We can see the computer name and the aggregated value, because that's what was asked for here in the query statement. Summarize aggregated value, count by computer. We're getting a number of missing updates on a per computer basis. Now, this is also interesting in that you can choose to export this information if you want to manipulate it a little bit differently. So we've got an export button here where we can export this as a CSV file. And from that, we could bring it into a spreadsheet, manipulate the data, graph it, or maybe use it as a list to send off to technicians so that it is in their list of duties, things to be taken care of immediately. Now, another aspect of auditing and watching for things in Azure, looking for suspicious activity, could also be looking at activity logs for Azure Resource Management itself. So, for example, I'm going to click on Home here in the Azure portal, and let's see, I'm going to click to open the navigator on the left, and let's go to the Virtual Machines view. I want to look at the activity for a specific virtual machine, so I'll click on it to open up its navigation bar. I want to look at the activity log. The activity log doesn't really deal with anything running within the virtual machine, like specific app software, but it does deal with the management of this resource in the Azure cloud. So we don't really see very much here for the last 6 hours. That's the default time span. So I'm going to say for the last week, we'll click Apply, and the filter will then show us any activity beyond just the last 6 hours. So we can see there were some audit policy actions applied to the virtual machine. Of course, you can click on any one of these to retrieve a little bit more detail. Also, if we take a look at the list of events, we could also see that there was the creation or updating of the virtual machine 1 day ago. We can also see the date and time stamp, as well as the user account that was used to do that. In the cloud, you then have a way that you can easily identify suspicious network and host activity, as well as any potential vulnerabilities in your environment. Timing is crucial in thwarting network attacks. After watching this video, you'll know how to configure alert notifications in Microsoft Azure that could indicate suspicious activity. To get started here in the Azure portal, in the top center search field, I'm going to search for Monitor, and I'm going to select the Monitor service. Now in the Monitor service, over on the left, I'm going to click on Alerts. What we can do is we can click the Manage Actions button, where we can configure notifications. So for example, I'm going to click Add Action Group. Now this action group requires some details to be filled in, notably how we want notifications to occur. So I'm going to call this Notify Admins, and the short name will be the same thing because that's a required field. Now what I want to do is go down and specify the action type. And from the drop-down list, we have all kinds of things that we can do. We can trigger an Azure function. So if developers have built a custom function hosted here in the Azure cloud, we can trigger it to execute as a notification type of mechanism. So presumably, the function would have some kind of notification built in, or it could be some kind of action that is taken to mitigate a potential security threat. We can also select email, SMS, push, voice, which I'm going to do. Now that's going to open up a new configuration window. Let's say I want to send an email message to a group called admins@fake.com. Now at the same time, we can also specify SMS text messages that should be sent to a phone number if we want notification to occur that way, or using Azure App Push notifications. However, all I'm going to do here, I don't want SMS text messages or push notifications or voice messages, just email. Now that we've got that selected and we've got it populated with an email address, I will click OK. Now we have to give a name for that, call that action group email admins, and I'm going to click OK. So we've now created an action group. Now we might have to refresh the screen here after a moment to actually see it displayed. And after a moment, it refreshes itself. So we can see that we've got our Notify Admins action group here. Now, the way that this gets used is in the following manner. Let's click on Monitor Alerts at the top upper left here in the breadcrumb trail. What I want to do is manage alert rules. Any existing alert rules will be shown. Here we've got one that's looking for failure anomalies for a web app. And if we actually click to open it up, we've got the resource, the web app that's being monitored. We can see the condition whenever failure anomalies criteria is met. If you're wondering what that means, we can click on it to look at it. It's an abnormal rise, for instance, in the number of HTTP requests that are made to the app that fail. So that could be indicative of some kind of a network flood or a distributed denial of service attack against the app. Down below, we can see the actions. Now, currently, it's going to email to Azure Resource Manager roles, but we can actually click Select Action Group and choose what we just created, the Notify Admins action group, which emails an admins group that we've defined. And then we could click Select and then save that. Now you can also build new alert rules. Let's go back to the rules view. I'm going to click New Alert Rule. The first thing to do, of course, is to select a resource. So I can filter here. Let's say I want to filter, well, I can even type in virt for virtual machines. So I'll choose virtual machines. We can see them shown down here under our subscription and our resource group. So I'm going to select both virtual machines. I could choose one or more. I'll click Done. So we can see that they're listed up here under resource. Now, what is it that we're interested in being alerted about those? Let's say it's high CPU utilization, which could be indicative of some kind of an attack or the machine having been compromised and perhaps being used as a cryptocurrency miner, which is very processor intensive. So down under condition, I'm going to click Add, and I'll just choose percentage CPU. it's going to give me a little chart so I can get a sense of how busy the CPU has been recently. Now, recently means by default over the last 6 hours. If I choose over the last 3 days, I can see there was a bit of a spike in activity, but that's still maxed out at approximately 9%. Not very busy. So let's go down and let's say that if the average CPU utilization is greater than 80%, that's definitely abnormal. Then that should be something I should be alerted on. So I'm going to go ahead and click done. So now we've got our condition listed. And if I go down below that, under actions, once again, we can click select action group like we did the previous alert rule. I'll choose notify admins, select, and as we go further down, we have to give this rule a name. Let's call it busy CPU abnormal. I'll click outside of it, and then down below, I'm going to accept everything else as a default and choose create alert rule. Now, if you get an error creating the rule, just go ahead and try again. It's usually because it's busy connecting to the cloud. So we can now see we have our busy CPU abnormal rule, which applies to our 2 target resources, and we've got the notification sent to be sent to administrators. Encryption provides confidentiality for sensitive data. In this video, you'll learn about the various ways that you can enable encryption for cloud-stored data. Here in the Microsoft Azure portal, I'm going to begin by clicking Create a Resource. Now what I need to do is create what's called a key vault. So I'm going to search for key and I'll choose Key Vault, then I'll click Create. The Key Vault is a centralized cloud storage location in which you can create or even import existing keys. So I'm going to specify a subscription here in Microsoft Azure. I want to tie this to and a resource group. Now you deploy items into a resource group because you can manage them as a single unit by managing the resource group. The vault name here will be KV1 for Key Vault 1. Now, if it says the name is already in use, it's because the name is not unique, and you're going to have to specify some name that makes it unique. So I'm going to specify a unique name. Now it's KV17234, and I'm going to specify that I want this stored in, let's see, Canada somewhere. How about we choose Canada East as a region? And that's it. That's all I'm going to change about this. I'm going to choose Review and Create. It'll check that my settings are valid. And after the validation is passed, we'll create the key vault by clicking the Create button. Here in the portal, I'm going to open up the navigator on the left and choose All Resources so we can see our existing key vault. Here it is, KV17234. That's the one we just created. So I'm going to click to open up the key vault. I'm going to click on Keys. We don't have any keys yet, so I can click the Generate Import button. I want to generate a key, and I'm going to call it Key 1. It's going to be an RSA 2048-bit key. I can also set an activation date of when the key can be used, as well as the time. When I do that, we get both options. And I can also set an expiration date and time of when it can no longer be used. I'm not going to do that. I'm going to make sure the key is enabled, and I'll click Create. So now I want to use this key with an Azure storage account. I want to use my own managed key, which I've just created. So I'm going to click the navigation bar over on the left once again, and I'm going to choose Storage Accounts. At this point, I'm going to open up an existing storage account that I want to enable encryption for, and I'll scroll down in the navigation bar and choose Encryption, and then I'll choose Use Your Own Key. So I get to select it from a key vault. So I'm going to click the Select link under Key Vault, and I'm going to select our newly created key vault, KV17234. Then, within that, I have to click the Select link to choose an encryption key from it. So I'll choose Select. There it is, Key 1. And then I'll choose Save. So what's going to happen here, it says that new data will be encrypted. Existing files will be encrypted retroactively by a background encryption process. So it could take time. HTTPS-enabled web applications use PKI certificates to secure HTTP network connections. In this video, you'll learn how to force HTTPS connectivity for a Microsoft Azure-hosted web application. To get started here in the Azure portal, I've already got a web application or app service deployed. It's called Web App Sample 172. If I click on it to open it up, in the overview area of this web app, we'll see the URL over on the right is indeed already using HTTPS, but the problem is that it's using the default name of the web app and the default Microsoft Azure DNS domain suffix of azurewebsites.net. Now, for a public-facing website, you'd probably want your corporate identity in your domain name. Now, it does work. If I click on it, it will open up the sample page for that web app, so it's functional over HTTPS. Problem is the name isn't meaningful and it's not related to a corporate identity. So what we're going to do for starters is scroll down in the navigation bar for the web app, and under settings, we're going to click custom domains. The first thing we're going to do is add a custom domain. I'm going to click the add custom domain link, and it's going to be www.lachanceit3.com. Let's say that's what I want this public-facing app to be known as when it comes to its name out on the internet. Now I'm going to click validate, and what it's going to do, Microsoft Azure, is it's going to verify domain ownership. Now what that means is I have to do that. It's not just going to happen magically. Down below, it's going to tell me that I need to create a CNAME record with my DNS provider using the configuration below. So a CNAME, www, that's the host portion, and then the value needs to point to our Microsoft Azure hosted web application. Now I've already got my domain name, in this case, lachanceit3.com, registered externally through an external DNS provider. So I'm now managing my domain name through my external DNS registrar, and down below, I need to make sure I add a CNAME record. So the CNAME is an alias record. Now, essentially, what I want to make sure happens here is that www within my DNS domain, so in this case, lachanceit3.com, I want to make sure that that points to, and then I'll just paste in, the default name used by our web application currently being hosted in Microsoft Azure. So I'm going to go ahead and click Save. And if it doesn't work the first time, just try it again. Sometimes the second time it'll take. We now have our CNAME record for www that points to our sample application. So far, so good. So back here in the Microsoft Azure portal where we were adding our custom domain, I'm going to click Validate. And it now knows that we've proven domain ownership by going and creating that record. Perfect. So that's one part that's been done. Now, if we go back to the overview for our web application, we can see it's still using the old name and not our custom name. Okay, well, one of the things that we have to do is have a PKI certificate, and we add a binding for HTTPS to our custom domain name. So I'm just going to go to our navigation bar icon over here in the upper left. I'm going to go to the All Resources view, because I've got a key vault here named KV1772. A key vault in Azure allows you to work with keys and certificates. Let's click to open it up. And I can see certificates over here on the left. So I'm going to click the Generate Import button. We're not going to import one. We're going to generate one. The certificate is going to be for our custom web app. I'm going to call it Custom Web App 1, a self-signed certificate. And the subject name here, CN for common name, equals www.lachanceit3.com. And I'm also going to enter that for the DNS name, www.lachanceit3.com. That's the public name I want my web app to be known by. I'm going to accept the rest of the defaults and click Create to create the certificate. Okay, so that's happening now. Let's go back into our navigation bar on the left and back to App Services. The App Services view is where we'll see our web application. So I'm going to click on that, scroll down in the navigator to TLS SSL settings. When I do that, I'm going to go to Private Key Certificates, and what I want to do is import one from a vault. So a vault certificate. We just made that in the key vault. So I'm going to choose the key vault here. There it is, KV1772, and the certificate for Custom Web App 1. Perfect. I will select it. It's importing it, making it available here for this web app. So now, if I go to the Custom Domains view, then we can start working with this. So if it's not showing in the list, you just have to go back in and add it. And I'll just pop in the name here, lachanceit3.com, and I'll click Validate again. You just need to make sure that you click the Add Custom Domain button after the domain ownership is proven. And it will be, because we already created the CNAME or the alias record. So add custom domain. When we do that, it'll then show up over here. There it is. It's not secured yet. So I'm going to go ahead and click add binding to the right of it. Now the binding here, I'm going to choose the certificate that we just imported, www.lachanceit3.com, and I'll choose server name indicator or SNI, SSL for the type of connection, and add binding. And after a moment, we'll see we now have a secure binding using our custom domain name with our self-generated certificate. Now, let's go back to the overview of this web app on the left, and notice the URL now reflects HTTPS and our custom domain name. Let's click on it to open it up. Now, it's going to say the site is not secure because that's a self-signed certificate. It's not one that was acquired from a trusted public certificate authority. That's okay. That's expected in this case. I'm going to click Details, go on to the web page, and we are now in. Now, of course, you could import the trusted root key for that certificate authority if you really wanted to have your devices trusted and not have that message appear. But at this point, we've secured a web application using HTTPS with a custom domain name. Now, the last thing we're going to do back here in the Azure portal is just take a quick look here at our TLS and SSL settings, and I want to make sure that HTTPS only is on. I do not want to allow HTTP unencrypted connections for this app. Allowing public access to manage cloud-based virtual machines directly can present unnecessary risk. After watching this video, you'll know how to configure a Jumpbox virtual machine as a single public point for administrative access to cloud-based virtual machines. So to get started here, in the Azure portal, I'm already in the virtual machines view where I already have a virtual machine named WinServe 2019-2. If I click on it to open up its details, we can then click on Networking to check out its network config. What's of interest here is that it has a private IP address of 10.0.0.5, and that's it. It does not have a public IP address. And generally speaking, it's not a great idea for every virtual machine to have a public IP and be directly accessible from the internet. So what we're going to do is deploy a new virtual machine that has both a public and a private IP on this subnet range, so that after we authenticate to the Jumpbox, that's the new virtual machine we're going to deploy, we can then in turn from it make a connection to private IP addresses to manage those hosts. Let's get started. So I'm going to go to the virtual machines view, and then I'll click Add up at the top. Now I can add a virtual machine using any type of operating system image that I'm comfortable with. In this case, it's going to be Windows-based. So I'll deploy this virtual machine into an existing resource group named RG1, and I'm going to call this virtual machine Jumpbox. I'm going to specify the geographical location where I want that to be deployed, in this case Canada East, because it's near where I will be administering from physically. And for the image, let's say I'm going to choose a Windows variant. Let's say Windows Server 2019 Data Center. I'm okay with the sizing here. So it's got 1 vCPU, 3.5 gigabytes of RAM. That's fine for what this will be used for. And I'll specify some credentials to connect to this virtual machine. And down below, I want to make sure RDP port 3389 is allowed, so we can RDP to the Jumpbox. And then once into the Jumpbox, from it, we can RDP to internal hosts. Internal meaning private cloud hosts. I'm going to go ahead and click Next. Now, we're really not going to change anything else here for the disks. It's going to have an operating system disk. That's fine. Next for networking down at the bottom. And I just want to make sure this is deployed into the same virtual network or VNet and subnet where the existing virtual machines are. Of course, you can route between cloud virtual networks, but I'm just going to do this to facilitate the process. I know there's nothing else I want to configure, so I'm just going to go ahead and click the Review and Create button in the bottom left. It's just going to validate my selections thus far, and once the screen refreshes, we'll see the validation has passed, and I'll click Create. So we're now deploying our Jumpbox virtual machine in the Azure cloud. And before you know it, it'll say your deployment is complete. So I'm going to click the Go to Resource button to jump into the properties of that virtual machine. So in the overview page, I'm interested in the public IP address, which I will copy. So I've started the remote desktop connection client on my on-premises station, and I've pasted in the public IP address of our jump box in the cloud, and I've specified my username that I specified when I created that jump box. I'm going to go ahead and click on Connect. And immediately, it wants the password for the account. So, okay, I specified that when I deployed the virtual machine. I'm going to go ahead and enter the password and click OK. Now, the first time I connect, it says, do you trust the identity? Sure, I do. Don't ask me again. I'll choose yes. And we are now RDPing into our jump box. We can see the public IP address listed at the top center here in the remote desktop bar. Okay, so I'm going to close the Server Manager tool that opened automatically. And here on my jump box, I'm going to go to the Start menu and launch the Remote Desktop Connection Client. I want to do this because from here, I want to remotely manage other cloud hosts that only have a private IP address. So we know that our second server that had only a private IP has an IP of 10.0.0.5. So I'm going to put that in here and click Connect. From here, I'm going to specify the credentials to log into that remote cloud-based virtual machine. And as expected, it asks me if I trust the identity. I'm going to choose don't tell me again, or don't ask me again, rather. I'll choose yes. And then we're going to be logged into 10.0.0.5 by going through our jump box. This way, we don't have to have a public-facing IP for each and every cloud-based virtual machine, which reduces the attack surface. Artificial intelligence, and more specifically, machine learning, are all the rage in a cloud computing environment. It works well in the cloud because the cloud has the ability to easily provision clusters of virtual machines that support this type of functionality. Now, if we take a look at what the definition of artificial intelligence, or AI, is, it would look like this. It's the mimicking of intelligent human behavior through the use of technology. Now, if we look at the definition of machine learning, or ML, it's a bit more specific. Essentially, we use algorithms to teach software models to make decisions and predictions based on ingested data. Now, that means that the ingested data has to be accurate and trustworthy. It has to be reliable. The machine learning data flow begins with the ingestion of data. Now, the ingestion of data, for example, might come from a series of IoT devices that support environmental control for buildings, or it might be a number of X-ray details, so that might be used by machine learning algorithms to come up with some kind of insightful outcome, a prediction, identification of a trend, or making some kind of an intelligent decision. But in the cloud, working with vast data sets and the enormous compute power required to analyze it to result in insights works well. The next consideration is how AI actually gets used. Now, in the cloud, we could use this for medical diagnosis based on ingested X-rays, or for looking at the performance metrics such as speed and tire pressure and the amount of fuel in self-driving cars. AI is also used for facial recognition, as well as for host and network behavioral analysis. So from the security side, we can ingest vast amounts of network activity, so network captures, host logs, and start making intelligent decisions about what might look suspicious. So the detection of phishing mail messages. It can also be used to automate system hardening if we see systems that are deviating from a pre-configured baseline for a security configuration. In the public cloud, we have options such as Microsoft Azure Sentinel or Amazon GuardDuty for Amazon Web Services. These are enterprise security analytics tools or services that ingest data related to users, devices, and apps and the related network activity. The idea is that these cloud services can detect potential security threats and even be configured with automated responses. And again, because the cloud scales well, it's very easy to make this happen at a cheap cost, as opposed to having to make an upfront capital expenditure or investment in clusters of equipment that would support this type of data ingestion and analysis. Distributed denial of service, or DDoS attacks, can prevent legitimate access to a cloud-based web application. This video focuses on DDoS mitigation techniques in the cloud, specifically using Microsoft Azure. To get started here, we're going to take a look at the DDoS protection plan options in the Azure cloud. So in the portal, in the top center, I'm going to search for DDoS, and we see DDoS protection plans. I'm going to go ahead and click on that. Now, we don't have any protection plans listed here. Every virtual network in the Azure cloud has some basic default protection against network flood type of attacks like DDoS attacks, but you can add a DDoS protection plan for enhanced mitigation against that type of security problem. So I'm going to click the Add button to add a protection plan. I'm going to call it Plan 1. I'm going to tie it to an existing resource group, and it's going to be tied to the Canada East region, and I'll click Create. Now, all we're doing at this point is enabling this enhanced DDoS protection plan. Now, in order for me to utilize it, I need to associate or configure each virtual network in Azure to use this plan. Let's just refresh to make sure it's there. And there it is, Plan 1. And if we click on it, we can open it up and see some of the details. Now, what I want to do is open up the navigator on the left and go to my virtual networks view. Now, in the virtual networks view, I'm going to open up an existing virtual network or VNet, because within it, I can enable DDoS protection. So I'm going to click DDoS protection. Now, the default is that it uses basic DDoS protection, but we can select standard and then specify our DDoS protection plan, Plan 1, for enhanced DDoS mitigation. So I'm going to go ahead and save that. Now, the idea with DDoS protection is to make sure that traffic from multiple bots or infected machine under malicious user control aren't allowed to flood the network or resources on this VNet with useless traffic. Penetration tests identify and attempt to exploit discovered network and host vulnerabilities. In this video, you'll learn about pen testing in the context of cloud computing. The first thing I've done here is gone to the Penetration Testing Rules of Engagement webpage for the Microsoft Azure cloud. Public cloud service providers always have a disclaimer and some documentation related to what is and what is not allowed when it comes to pen testing cloud resources. So if I scroll down a little bit and start to read this, we can see the scope that is covered by this document for the purposes of pen testing. So it includes Microsoft Azure services. Now, as I scroll further down, it talks about reporting security issues that you might inadvertently discover related to the Microsoft Cloud Computing Platform. It's not required, but ideally, you would fill out a form and report the security vulnerability to Microsoft. There are links to do that. But further down, you have to be careful about your pen testing. First of all, it says here that as of June 15, 2017, Microsoft no longer requires pre-approval to conduct a penetration test. Well, that's fine if you're an Azure customer, but make sure you look into it if you're using any other type of public cloud provider. Then the rules of engagement. Now, there are prohibited activities, things you cannot do when conducting a pen test in the cloud. The first one should be obvious, really, but sometimes lines can be crossed. We want to be very careful that we don't scan or test anything belonging to other customers. You can only access data that is entirely your own. You cannot perform any kind of denial of service testing. So if you want to test your app's resiliency against denial of service attacks, you won't be able to do it here. It's not allowed. So it's important to make sure that you are well versed in the pen testing rules of engagement for your cloud provider. Now, if you are going to conduct pen testing, you can use any tools you might normally use even on premises, such as Kali Linux, which we're going to deploy here through the Azure portal. So I'm going to click Create a Resource in the upper left. We want to deploy a virtual machine. So what I'm going to do here is actually search for Kali, K-A-L. For Kali Linux, there's Kali Linux. Kali Linux is a Linux distribution that contains hundreds of tools for security analysts. So I'm going to go ahead and click Create to create this. We're going to have to specify some further details, of course, before this is up and running. So I'm going to deploy this into an existing resource group in Azure, and I'm going to call this Kali. That's the name of the virtual machine as it will appear here in the Cloud GUI. I'm going to deploy this in a region that is geographically near where I am working from, Canada East in this case. And I'm going to scroll down because I want to use SSH public key authentication, which means I have to specify a username and I have to generate a key pair, private and public. There are all kinds of tools that are free that you can use to generate public and private key pairs, but here I'm going to use the free PuTTY key generator, which I've downloaded and installed. So I'm going to generate a public and private key pair. I'll click the generate button, and it's going to ask me to move the mouse everywhere so that we can have some kind of randomness in generating the mathematically related private key and the public key. Once that's been done, we're good to go. So what I want to do is specify a passphrase here that I'm going to use when I want to access the private key portion. The public key portion we're going to paste into the public key field in the background here for our new Linux virtual machine. The private key we need to save. So we've got some save options, save buttons to save this down below. So I'm going to go ahead and save both the public and the private keys. Now I've opened up the public key file I just saved in WordPad, and we can see we've got this public key information, which I'm going to select and copy to my Windows clipboard. Back here in the Azure portal, I want to paste that in the SSH public key field. I'll just click outside of it and looks good. So only the public key gets put here, not the private. We're going to allow inbound SSH traffic. That's good. So I'm just going to go ahead and choose review and create. Now, while the validation passed, the great thing about Azure is it gives you little security recommendations, and it says you've set the SSH port to be open to the internet directly. That's fine for testing, but you don't want to leave this for the long term. Instead, you might require a VPN connection and make sure that the Linux virtual machine here is only available after successful VPN authentication. However, for this purpose, it's fine. I'm going to go ahead and click Create to deploy that Kali Linux virtual machine that we can use for pen testing. After a moment, we get a message stating that the deployment is complete, so I'll click the Go to Resource button because we want the public IP address. We're just going to verify we can connect to it. So in the overview part of our Kali Linux virtual machine in the cloud, I can see the public IP over here on the right, which I will click the copy icon so I can get that on the clipboard, and then we're going to connect into that virtual machine. So here I've started the free PuTTY tool that I've downloaded, and I've placed the public IP address of our virtual machine in here, port 22, but over on the left under connection, down under SSH auth, I'm going to browse for my private key file. The public key is stored with the VM. We have the private key saved. So I'm going to specify that here. And then I'll click open to open a connection. And the first time we connect, we're going to get this message that asks if we trust the unique fingerprint for this server. Well, I'm going to choose yes. And in this case, I'm going to specify my username credential that I specified when I deployed this virtual machine. Now it wants the passphrase for the key. That's for the private key file. So I'm going to go ahead and enter that. And then after a moment, I'm in. So if I type clear, we can see that I am at the command prompt in Kali Linux, and we are now ready to use any of the available tools that we might want to use. For example, using the Hydra brute force tool. Here we can see the help screens for it. So we're ready to begin our pen testing in alignment with what's allowed with our cloud provider. Controlling resource access in the cloud is similar to how you would do it with an on-premises network. Let's take a few minutes to talk about cloud hacking tools, which are interesting because the same tool might be used legitimately by security auditors and pen testers, and those same tools might also be used by malicious actors for attacking a network or resources within a cloud-based network. The January 3rd, 2020 article in Forbes magazine includes a very interesting quote from Martin Giles, stating that nation-state hackers are now the biggest threat to cloud security. Why is this relevant? Well, because no longer are we limited to potential attacks from teenagers living in their parents' basement, working on their computers and using hacking tools. Now we are talking about potentially hostile nations that have very deep pockets that are funding some of these types of attacks. So it means we really need to be on our guard, and we really need to secure resources carefully, especially when it comes to the use of cloud computing. The first thing we'll get into here is network sniffing. Now, if you've worked in network computing environments for years and years and years, this is old news. You have the ability to capture network traffic on a wired or a wireless network, given that you are positioned on that network in a place where you can see the traffic going by, so to speak, and that you have the right tools and you know how to use them. So what's great about this is that you can capture traffic and it can be saved into a file and analyzed at any time in the future. There are even online resources where you can upload your capture files and have them perform a detailed analysis. And this can be used to track network activity to make sure it's legitimate, to look at network performance indicators, and of course, it can also be used by attackers to try to learn about what's going on the network, perhaps even see things that aren't encrypted being transmitted. Now, there are many tools that can be used for network sniffing, things like Wireshark, TCP dump, which is a built-in command in many Linux distributions, Network Miner, even in the cloud, the Azure Network Watcher tool for network monitoring can be used. Here I'm using the free open source Wireshark tool. I've downloaded and installed it, and I have a packet captured on a network. Now, when you view an individual packet capture, it shows up as one row here in Wireshark. And when you select it, in the center part of the screen, you can break down all of the different parts or headers of that transmission. For example, the Ethernet 2 header has source and destination hardware or MAC address information. We have the Internet Protocol or IP version 4 header, which includes many fields, but it also includes things like the source and destination IP addresses. And in this particular case, we've got a TCP header, Transmission Control Protocol, with port information, and so on. Now, as I browse through a packet capture, what's interesting is if I suspect that I might have some traffic here that is not potentially encrypted, for example, HTTP traffic, if I were to select that transmission, and here in Wireshark, go up to the Analyze menu, and then go all the way down to Follow TCP stream, it puts it all together in a digestible form, meaning that I have the potential of seeing what the username and password are. For example, a username here of beef and a password of beef. Now, this is easy to spot because the traffic has not been encrypted. So the lesson here is not only should we be encrypting sensitive data that's stored, data at rest, but also data in transit being sent over a network. Some other common attacks we should be aware of, and this one is related primarily to a web app, is a server-side request forgery, otherwise called an SSRF. The way this works is that in step 1, a malicious user would send a modified URL to a web application. They have to know how to send that URL to take advantage of a vulnerability in the server-side app. So because the traffic looks like legitimate traffic, such as HTTP or HTTPS traffic, the app takes in that URL request. But this is where the vulnerability really resides, in that the app doesn't properly validate the URL. It simply follows the instructions in the URL, such as to fetch a resource from another location, like a URL on an internal server on an internal network. And so attackers can then use that vulnerable server essentially as a proxy or a jump server that they use to go through to get to internal resources. The requests to internal servers would appear to have come from the vulnerable server, which in fact they would have. So software developers need to adhere to secure coding guidelines to treat all supplied user data as untrusted and then to validate it to make sure it is legitimate. Now, there are a number of different cloud hacking techniques and tools. Let's take a look at a couple of them here. Google Cloud Platform GCP Bucket Brute, and also the AWS S3 Bucket Exploitation Tool. These are tools that are designed to attack cloud-based storage. A cloud-based bucket is a storage location for files. So these are designed to scan storage buckets to determine how accessible they are. For example, in AWS, you can set an S3 to be publicly accessible. And what that means is that people don't have to authenticate to get to the contents. And so attackers can use tools to scan for these things, looking for these types of potential weaknesses. The AWS Pwn tool, PWN, this is actually a suite or a collection of hacking tools for specifically getting into AWS environments, such as restarting EC2 instances, which are virtual machines, but having them restart with custom injected user code, which of course would be malicious in this context. It also contains tools that are designed to remove the attacker's tracks, remove audit trail events that are related to security compromises. There's Dumpster Diver, which is a tool that's used to scan files looking for security keys. What are security keys? Well, let's say in the context of AWS, each user can have their own unique set of security keys that will allow programmatic access to some or all aspects of AWS resources. And so this tool would normally be used when a cloud technician's computer or device has been compromised. Other examples of cloud hacking tools would include CloudGoat 2. What this is an intentionally vulnerable AWS environment that's designed for testing purposes. So for security technicians to practice how attackers might use certain techniques to break into cloud-based accounts like AWS accounts and go through the resources. Then there's Pacu, which is another AWS vulnerability scanning or testing toolkit. This one is open source. And we also have Nimbo Stratus. This one, again, is related to AWS. It's designed as a vulnerability scanner to detect any security misconfigurations, such as EC2 instances or virtual machines, which might allow some of their data, their metadata, so data about the virtual machine and its configuration, to be downloaded. The idea being that the more that attackers know, the more that they can use that information to potentially break in. So think about your cloud environment. What do you have running? Which platform is it running on? And how often are security audits or security tests conducted? This is something that is an ongoing task that needs to be considered. And also, not only running things like security audits, but viewing the report findings and putting recommendations into effect to further harden the cloud environment. Okay, so at this point, we've covered a lot of cloud security potential vulnerabilities and how you might mitigate their impacts. Let's focus now on cloud security best practices. As we're going through this discussion, I'd like you to think about how your organization is using cloud computing services and how some of the things that we will be talking about could apply in terms of hardening those cloud services. Let's start with the Cloud Access Security Broker, CASB, otherwise just pronounced CASB. What is a CASB? Well, its purpose is to control access to cloud resources. Now, that's a pretty big umbrella statement. So what does that really mean? Well, it can mean data loss prevention. In other words, we want to make sure we limit data exfiltration possibilities, sensitive data being taken out of the organization, such as from cloud services like databases or storage buckets. Cloud governance, which means that we want to make sure the use of cloud IT services adheres to the appropriate regulations, laws, data privacy standards. You can go to a public cloud provider's webpage documentation for their site and read up on their compliance with regulations like GDPR for the European Union or PCI DSS for credit and debit cards. So examples of CASBs include Microsoft Defender for Cloud in the Microsoft Azure environment, the use of Microsoft Azure conditional access policies, where numerous conditions would have to be met before allowing access to resources such as cloud-based apps, or using tools like Cisco Cloud Lock or AWS IAM policies. This is but a small list. There are many CASB solutions out there. Another best practice is to use a jump box. In Microsoft Azure, as per our screenshot, that's called Bastion. Now, the idea is that we have a jump box, a server, a virtual machine that has a public interface, so it's reachable from the internet, but it also has a private interface connecting to an internal cloud network where virtual machines with only private IP addresses reside. So what this means is we do not want our virtual machines to have public IPs and thus be reachable directly from the internet for security reasons. So in this example, what's happening is the Microsoft Azure portal, the web GUI, is being used where the credentials are being specified to sign into a Linux virtual machine. And this is all being done through the Azure portal. You don't have to use some other tool that would require a direct connection to the virtual machine. The other thing to think about is serverless computing. What this really means is that there are still servers being used for given services, but those are underlying servers that are managed by the cloud service provider, including the updating of the software in those servers, the OS and any apps that are installed. So we don't have to worry about it as cloud customers. Now, examples of how this would be used would be to host cloud-based functions if you're a software developer. You can just focus on thinking about your code and what the function should do instead of worrying about setting up the underlying infrastructure. The same would be true for database admins, just deploying databases in the cloud as a managed service where the underlying OS and the virtual machine and the database software is installed for you. Now, where are the best practices in all of this? Well, you can do some of the things you would do on premises that would be just as effective in the cloud, such as limiting network access, determining who can be on the network in the first place, and that is done in a number of ways, such as with proper firewall configurations and also enabling things like multi-factor authentication to make it hard to sign in, not just to sign into an app, to sign in to even gain access to the network in the first place. Then we have the notion of edge computing that we need to be aware of. What this means is that we have some kind of compute processing occurring not just centrally in the cloud, but on the network edge. What does that mean? It means on premises. It means in a content delivery network environment. With on-premises configurations, we can have a hardware appliance provided by the cloud provider, or it could be a software appliance, which really just means it's a virtual machine that you can download from the cloud provider that runs on-prem. And what it would do is do some kind of local processing, maybe anonymizing data, and that can even be customized. The other thing to think about is the examples of where that would be used. So ask yourself, are we using Amazon Web Services Lambda functions? And if so, are those functions running on the edge, such as in a content delivery network, a CDN? A CDN is a cache or a copy of origin data, like files from a web app, that are copied to a certain region to make it closer to users that will request it. So when they request it, they get it quicker. But the difficulty here is that we have stuff running all over the place, and the term for that is fog computing. It means that we've got cloud computing service components, on-premises components, and edge computing. Just imagine that as a security technician, you have to determine where those components are running, the fact that they are running in those locations, and also their interaction with one another. This is absolutely crucial in making sure that we properly harden the use of cloud services that might be distributed. Now, we've already talked about application containers, so what can we take away from this in terms of security? Well, it might seem obvious, but it's always important. Harden the underlying host server where you're running your application containers. Make sure you apply software updates and limit who can gain access to that host. Use only trusted container images from trusted locations, which might be a private image repository hosted by your organization. You would have to know if that's being used. So it's something you should add to your list. What do I need to check to see that we are using it in a secured way? The next thing to think about is setting resource limits for each container. We do not want application containers to have full reign over the host they're running on, including using all resources like CPU processing and RAM. So do not run containers with the dash privileged flag. There would be very few cases where you would want to do that. So generally, we do not want to do that. Configure containers to run as unprivileged users. When you're running stuff on a machine, background services, you can determine an identity under which they are running, and that identity should have limited permissions, only the permissions required to run properly. Consider disabling inter-container communication where it makes sense. Doesn't always make sense, because you might have an app consisting of multiple containers that talk to one another. But you would have to have knowledge of that configuration to make that kind of decision properly. Finally, you should consider using security profiles to control what application containers can do. You can do this using things like Security Enhanced or SE Linux, or software products like AppArmor. So take a minute and think about how your organization might be using application containers, and ideally make a list of these types of hardening options for the containers and make sure that they are being adhered to. The last thing we'll cover here is the OWASP Top 10. And the OWASP Top 10 lists the top 10 security vulnerabilities for web apps. So for example, item 1 is broken access control. Item 2 is cryptographic failures. We're not going to go through the entire list in detail because there are other LinkedIn library courses that focus on web application security as well as the OWASP Top 10. But it's important to be aware of it. Whether the web app runs on-premises or in the cloud makes no difference. A lot of this boils down to software developers adhering to secure coding guidelines. All right, so we've covered cloud security best practices as they relate to various cloud service deployments. The last thing I'll leave you with here is why not take a minute or two and consider which services your organization is using in the cloud, but the key here is to make a list of those services that need to be secured. Ideally, you will have an inventory, even an automated solution that generates an inventory of cloud service deployments. After having gained some knowledge about securing the cloud from a certified ethical hacker perspective, what's next? Well, the next thing to consider is to track cloud provider security updates. So if your cloud provider is Amazon Web Services or Google Cloud Platform or Microsoft Azure, make sure to check constantly to see if there are any updates or improvements from a security perspective to existing cloud services. This also means adhering to security best practices for each cloud service. You should then enable the secure use of cloud services that provide business value. So if your organization, for instance, needs to ingest large amounts of data to predict future trends in the financial sector, let's say, then you should look at the appropriate cloud services that can do that and make sure they are configured to do it in a secured manner. You should run periodic cloud vulnerability scans to assess your organization's security posture. You should also consider running periodic cloud penetration tests to see how exploitable some of those discovered vulnerabilities actually might be. When you do look at running vulnerability scans and cloud pen tests, make sure you adhere to the cloud provider rules of engagement for those purposes.